This is acids and bases naming notes. These are going to rely on your skills to remember all the way back to when we did ionic and covalent naming of compounds. So I highly suggest that you either find those notes or look them up on my teacher page, because all of the old notes are still there under a little box on my teacher page that says semester 1 on it. But I'm not going to give you a super detailed recap. You can do that on your own because we already learned that. To start with, talking about acids. Acids contain or start with hydrogen. We went over that in the previous set of notes that I uploaded for you. They could either be hydrogen that's bonded to an element or hydrogen that's bonded to a polyatomic ion. So popular examples of acids would be HCl, H2S, or H3PO4, and we're going to go over how to name those here in a second. For bases, you should already know that they contain or end with a hydroxide polyatomic ion. So examples of that would be CaOH2 or LiOH. There are countless others. And just so you know, not every single base in existence always contains hydroxide. That's just generally what bases look like. We went over an example of something that is a base that does not have a hydroxide in it. Ammonia is a popular example of that. But I digress. Moving on. So if you're going to name an acid, hydrogen with a monoatomic anion. So let's go over the word monoatomic just in case I lost somebody. Mono meaning one, and atomic referring to atom. So if you're hydrogen bonded to a monoatomic anion, you are hydrogen bonded to one other atom with a negative charge. So your first step in naming those types is to write hydro, and that hydro represents hydrogen. Then you are going to name the anion. You're going to remove that IDE suffix that's always there on the anion were it named regularly, and you're going to replace that IDE with ic. And then after that, after you've put hydro, you've named your anion, then after that you're just going to write acid. So to give you examples of how to do that, I have HCl. Now, everything in blue that you're going to see from here on out, that's how you would name it using normal rules, either covalent or ionic rules, depending on what that is. So in this case for HCl, what's in blue for you right now is if we had used covalent rules to name this. I would have named it hydrogen monochloride, which some of you may have already guessed. But if we take into account our acid naming rules, and this is an acid, hydrochloric acid, as you see highlighted in green, that's the proper name, you're going to take the entire first part of it, hydrogen, and you're just going to take the hydro part of it. That's it. Hydro goes first because that represents our hydrogen here. Then you are going to name your anion, which in this case is chloride or chlorine in its neutral form. So to name your anion, you take that chloride that would normally be in the actual regular covalent name. You take off the IDE ending. You completely cross this out and you put ic on the end of it. So you have hydro and now chloric instead of chloride. And that's this first part, hydrochloric. And then after that you just write acid, hydrochloric acid. For this next one, we have H2S. And normally if I was naming covalent rules, again to name that, I would name that dihydrogen monosulfide. So once again, there's hydrogen there. So we are literally just going to take the prefix hydro. That's it for this part. So there we have this, hydro. Then we're going to name our anion here, and we are literally just going to take this last part. I don't care how many sulfurs there are, 1, 2, 12, 27, it doesn't matter. You are just going to take the sulfide, cut off the IDE ending, and put ic. So now we have hydrosulfuric acid. Now a couple of you might be asking yourself, well, why in this one is it chloric, but in this one we took the full word and we did something else. So we didn't go chlorinic acid up here, but we have the entire word. Why is that a thing? Because it sounds better. That's really the only answer I can give you. There may be a technical reason as to why that is, but honestly what I found in, especially with naming rules, is because it sounds better is the answer for a lot of things. So hydrosulfuric acid would be the name of this one. So for HF, to figure that out without the name straight in front of you, I did give you what you would normally name that using covalent rules. You'd name it hydrogen monofluoride. So now we're going to kind of figure this out together. We're going to figure that out. And just like we did before, for the H, we're literally just going to take the prefix hydro. And I'm going to do this in black. So we have hydro. And then we want next our anion. And we have fluoride as our ion name, fluoride, but we cross off that IDE ending and we put ic. So fluoric, because you'll notice that ic in place of the IDE, we put a space and we write acid. And that is how you're going to name any acid that you come across. Okay? Now, these types of acids are not the only types of acids you're ever going to run across. It's not always going to be hydrogen bonded to a monoatomic ion. Sometimes it's going to be hydrogen bonded to a polyatomic ion. And in that case, you're going to write the acid name a little bit differently. So for naming acids for hydrogen with a polyatomic ion, step 1, you do not write hydro. Just don't do it. Skip that entire step. Don't write hydro. Don't do it. Don't do it. Don't do it. You are literally just going to add the ending of the polyatomic ion. So anytime you would see ate, such as sulfate, phosphate, whatever, you're just going to change that ATE to IC. So ic, like we've been doing before. And anytime you see ITE, that ite ending, that a lot of you got tripped up on before when we were trying to name ionic compounds, anytime you see that ITE, you're going to replace that with OUS. And then, just like before, we're going to make space and write acid. All right? So, moving on to our examples. We have H2SO4, which if I was using those rules to name this, if I was using covalent rules, and I'm sticking with covalent just for the sake of normalcy, you guys, if I were to name that using covalent rules, I would name it dihydrogen sulfate. In this case, since it is a polyatomic ion, I am going to completely cross out this entire word. There's no hydro prefix, there's no how many hydrogens do you have prefix, nothing. All you need to worry about is this last part, this sulfate. And you are going to cross off the ATE ending, replace it with IC, because if you remember from the previous slide, ATE gets replaced with IC. Make a space and write acid. So this entire thing is sulfuric acid. Now, this one, HNO2, on the other hand, NO2 is nitrite. It is not nitrate. So, the same thing you did before, you're going to completely discount, cross out, scratch off this entire word, but instead of the IC replacing ATE, now you have OUS replacing your ITE. So you have nitrous acid. And so down here, we're going to do another example together. You don't have the answer for you right in front of it. So this is still a polyatomic ion. We still have phosphate here, as I gave you in blue. We don't care about the hydrogens in this instance because phosphate is a polyatomic ion. So, in this case, we are going to take the root of the phosphate, and yes, this is going to sound a little bit different. It's not going to be phosphic acid, it's going to be phosphoric acid, because what you're really doing is you're taking the root word of phosphorus, and again, why does it look different than you would name the polyatomic ion? Because it sounds better. And I do apologize for that confusion, but it is phosphoric space acid. Oops. Let me highlight that in green. Okay. Now, naming bases. Happily, naming bases is a heck of a lot simpler than naming acids because there's nothing special that you do differently from how you would normally name this using ionic rules. So, CaOH2, you would name calcium hydroxide just like you would name it normally using those rules. There's no weird prefixes or suffixes or anything for bases, and that should make you happy because it means that you don't have to learn new things for bases. It's just acids. I will ask you to go backwards at some point. So if I give you the acid or base name, I expect you to be able to write the formula for that. So remember your swap and drop rules. You're just going to have to relate them a little differently to different names. If it says hydro in front of it, hydro something, there's a hydrogen and an element. So that's like hydrochloric acid, something like that. If there is no hydro, and it says acid, it's hydrogen with a polyatomic ion. And if it ends with hydroxide in any way, shape, or form, it is a base. If you see the word hydroxide, it's a base. So examples of that, you have lithium hydroxide. You can go to your polyatomic ion chart or look up a polyatomic ion chart if you don't have one in your possession. That's going to be LiOH. And you would figure that out because you can go to the periodic table, you can look at lithium, it has a charge of +1. On your polyatomic ion chart, you can go to that, hydroxide has a charge of -1. Swap, drop, reduce, LiOH. Hydronitric acid, so this is hydrogen bonded to a nitrogen, and you know that it's not nitrate or nitrite or whatever because there's that prefix hydro. You would go to your periodic table, figure out that hydrogen has a +1 charge. You would go to your periodic table, figure out that nitrogen has a -3 charge. Swap, drop, reduce, you get H3N. For sulfurous acid here, you know that there's a hydrogen there because it says acid, but you also know that there is a polyatomic ion there because of that OUS and the lack of the prefix hydro. But you know hydrogen's there anyway because there's an acid. So you just have to figure out what polyatomic ion you have. And with that OUS, you know that it's sulfite instead of sulfate. So you would go to your polyatomic ion chart. You would find sulfite, which is SO3. You would figure out that it has a -2 charge from there. You'd go to your periodic table and look up hydrogen again. Hey, guess what? It still has a +1 charge. Swap, drop, reduce. You get H2SO3. So hopefully you still know how to do that. If you don't, again, please, please, please go back to my other notes that are still on my teacher page. Relearn how to do swap and drop rules, watch a YouTube tutorial video, something, because once again, this stuff is never going away. And if it confused you then, it's still going to confuse you in the future until you really truly learn how to do it. So I hope that this was helpful. Email me with any questions that you have. I'll be posting assignments and more tutorial videos as I go. Stay safe. Have a good day.